So if you get two sides and one angle, then there's a possibility they could have one, two, or no triangles. So see if I can give you find a picture here from your book. So if the angle changes, it's like you're shifting that side somewhere else and then closing it off. So it might not close, meaning there's no triangle. 9.2. Okay, there it is. So here's the notes from the book. So picture, let's say they give you A, right? But you don't know what's going on over here. So this angle could go all the way down here, or it might actually close inward, like go this way. So it really depends how it's going to happen. So depending on the angle up here, this will either go outward or inward or whatever, which will then change this corner wherever it lands. So because of that, you could have multiple triangles. But if the question gives you two angles already, then it's not possible for two angles to exist, or sorry, two triangles to appear because it's already fixed. You see that? So over here, it's not fixed. So that's what we're gonna do. So here's a better picture right here. So if your angle closes this way, then you have a new B and a new C. Then you have the other C over here and the other B over there. So if it opens up this way, that's one triangle. If it opens up the other way, it could be a different triangle. So that's what they mean by two. And I'll show you how to determine it when we're using law of sines. Okay. When you're using, so if you're given two angles, you don't have to worry about it. If you're doing law of cosines, you shouldn't have to worry about it either because the cases will, uh, you'll have the two cases you use law of cosines for will not have multiple triangles. But let's see how it happens here. Okay, so, all right, let me find out what they gave us. I forgot. So I said two sides and an angle, right? Okay, here it is. So here's A, here's B, and C, the angle sides. The angles, not the sides. So the only angle they are going to give me is 140 degrees for B. Little b side is going to be 7. Little c is 5. That is all they're giving me. Okay, so we can use the law of sines, excuse me, to find uh, A or C, but you're going to have two different A's and two different C's, possibly. So then we have to determine, like, all right, if I use the alternate C, does it still form a triangle? When I sum, so the one way to check is once you have all three, right, you add them all up and see if it's too big. If it's too big, then you realize, all right, that other C that I found is not a solution. So there will only be one C, meaning one triangle. Okay, so when you're solving for A or B using the inverse sign, which we'll do in a minute, you're going to have two different C's or two different A's, depending which one you solve first, which will then determine the other one, right? Because they have to add up to 180. If they do not add up to 180, then they are not solutions. So let's go ahead and solve like we did last time. So we have A and B, or sorry, we have these B's here. We do not have any of the A's, but we do have this C. So we should be able to find big C. Okay, so I can set the equation this way. Sine C over little c is equal to sine B over lowercase b, right? So I'm going to solve for C. So we'll multiply both sides. This time I'll go ahead and show the algebra here, just for fun. So these C's cancel. So now I have sine C equal to C sine B over B. Okay, so you'll take the inverse sine of both sides, right? Inverse sine of both sides, C sine capital B over B. So this implies that C, the angle C rather, big C, is equal to sine inverse of all this stuff. So plug that into your calculator. Right, what will we get? I guess go ahead and plug in the numbers too. So that would be sine inverse of 5 sine, I don't have space anymore. Oh well. Sine inverse of 5 sine 140 over 7. So what is that going to be?
$27.33.
Yeah, that's right. 27.33 degrees. So this is, we're going to call it C1, right? So C1 is equal to 27.33 degrees. Now, there's a possibility that there's another C if there's a second triangle, but we got to test it. So use the coterminal side to find that angle, and then you check, is it too big? Does it work? So 180 minus 27 will give me the other angle.
152.67.
Thank you. 152.67. So looking at this angle and looking at the one that was given, this is fixed, right? Is C too big when you have looking at B?
Yes.
Yes.
Right, because B is 140 degrees. If I add that to C2, that's beyond 180, right? And I still haven't even accounted for angle A. So this right here is too big. So since C2, well, so let me write this a little more elegantly. Since B plus C2 is greater than 180, then C2 is not a solution. Which means we only have, which means we don't have two triangles. We'll phrase it that way. So we will only find one C and one A. Okay. So if C, right, this is the only C that we need. If C is 27.33, what is A going to be?
12.67.
Yeah.
So, Jack, weird
Uh-huh.
question.
What's up?
If there's supposed to be two triangles, why doesn't it equal 360?
So if there were two triangles, then C1 and C2 would both work because the sum of all three angles must add up to 180, right? But since this B, the one that cannot change, the 140 plus the one that I found, the possible C2, when I add them up, they're beyond 180. So this is not a solution because of that. I can't use it.
Okay, I got you.
But if you were to have added it to B and it turns out that it's smaller than 180, then you would find another A that corresponds to this one. And then you have a different A that corresponds to this. So you have two different A's, two different C's, which would then change your sides.
Okay.
And in this case, it would change A side, right? Because these are already fixed, right? So basically,
Okay.
you'd have like the A flopping outward, right, this way, or maybe inward. So that would change this length because you have two different A's and C's, like the picture I showed you earlier.
Okay. Gotcha.
Okay, so we'll use this one. We got A, so now we need is little a, right? So I'll go back to the law of sines. Sine A over sine, or A over sine A is equal to, I'm going to use the ones with the exact numbers. So I will use B over sine B because I have 140 and 7. Those are pretty numbers. So solve for A, that would imply that A, oops, sorry, I'm too low. That would imply that A, right, solve for this, is equal to B sine A over sine B. Plug it all in, that would be 7 sine 12.67 over sine 140 degrees. Is there any, oh, hold on a second. Is there any questions so far? Is that making sense?
Oh, I have one. I'm sorry. I don't know on my calculator. How did you get the words 27.33? Can you show me how you did that on the calculator?
The 27.33, oh yeah, this one, right? This part?
Yes,
Sure. So is this too bright? Can you see it?
I can see it.
Okay, so you do sine inverse. Once you have that open, I recommend you call the fraction button by hitting alpha and y equals, if you have a TI-84, that is.
Okay, alpha.
Then y equals, and then choose
Y
fraction, the little symbol. That way it'll be easy to type it in. I'm sorry?
I'm looking for the y equals.
It's at the top, upper left here. Sorry. Here.
Oh, okay, hold on.
So alpha, and then press that button. It'll allow you to choose for fraction stuff.
It gives me the plots.
We have to hit alpha first. And then y equals. It should look like this. Let me try it again. It's alpha, y equals, and then this little menu pops up.
I have the TI-84 and it's giving me plots too.
You hit
Yeah,
alpha?
I have the TI-83, but it's giving me plots.
So the alpha button doesn't work when you try it,
Not alpha and y equals.
and it doesn't.
Gives me plots.
Yeah.
I see. It might be 84 plus thing, perhaps. Anyway, we don't need that. That just makes it prettier. So sine inverse, so let's do it the way we're supposed to. Press 5, sine 140, close parentheses, divide by 7, close parentheses. So there's my 27.33.
See, I get 0.7756.
Do you have it in degrees? Check mode and go to where it says, mine might look different, but look for, change it to degrees.
Oh,
under-
put it in degree? Okay, got it.
Yeah.
When I put it in degree, I hit enter.
Right, and then just redo that. You can hit second. I'm hoping you hit second and then enter, and it'll let you do the last thing you did.
Okay.
This time it should come out in degrees.
Second and enter. Oh, yes, thank you.
Okay. So that's how we got this angle, and then you can
Yeah.
use that to find capital A, right?
Okay, that was my only question.
Okay. So now just punch this guy in, and we should have our final piece. So 7 sine 12.67 over sine 140, right? Okay. So I'm getting 2.3, we'll say 9. 2.39. So since I only had one triangle, I only had to find one of each, right? Like the last two examples. But at this point, we need to start checking, okay? Because you never know when you'll have two triangles or none. None happens when you're trying to find an angle. Like if you were, let's say you were trying to do this, like we just did in the calculator a minute ago. If you're trying to do this and then you got an error, then there's a good chance that there is no triangle. And you should just say no triangle and stop there. Okay. Any questions on example 3? Any other questions? Okay, so let's do one that actually has two triangles now. Okay, so that one was just us checking, and it turns out there wasn't. This time there will be. But we will check the same way. Okay, so we're given example 4. Two sides and an angle are given. Determine if the given information results in 1, 2, or no triangles. Okay. So let's see here. I'll call this A1. Little a1 for my first triangle. B will be the fixed part that they're going to give you. So there'll only be one B. So this is given to you as 20 degrees. Little b is 9. Okay. They also give us a little c, which is 11. There will be, just to make this a little easier, it'll be a C1 and an C2. Okay, so then over here, I'm going to put A2 A2. Of course, you wouldn't know this ahead of time. I'm just doing it so the notes are a little neater. We don't know which ones would be, you know, in the actual question, all you would get was B is 20, B is 9, C is 11. That's all you're going to get. Okay, so this is me just trying to make it a little easier to understand. Okay. Alrighty. So just because I know for a fact this question is going to have two triangles, I set it up this way. They will not tell you. But we're going to approach it just like we did the last example and pretend we don't know. So I have an angle and its opposite side. So I'm going to use this to help me solve for missing pieces. Just like the last one, I'm going to use it to find the missing C here. Okay, then I'll be given, once I do that, I'll have two different C's. I need to check if it works. Okay, so here we go. So sine C1, I'll just call it C for now, right? Sine C over little c is equal to sine B over B, which implies that, I'm going to skip some algebra here, sine inverse, well, no, it's fine. I'll just show this little step here. Implies that let's see, yeah, sine C is equal to C sine B over B, which means that when you do the inverse of both sides, you'll have C equal to sine inverse of all this stuff. Which is equal to sine inverse of 9, 11 sine 20. So what will
Is
C
that
be? Uh-huh.
is that minus sine inverse or times sine inverse?
This is sine inverse of, so this is an argument.
And the little sign in front of it,
The -1 means the is denoting inverse.
in front of the S? Or am I tripping?
Oh, this is equals. Is that what you're talking about?
Thank you. Yes.
Okay. All right, so what did you guys get for C? Me. I got 24.
24.7.
All right, cool. That makes me feel better. Thanks, man. So C1 is 24.71. C2 will be 180 minus 24.71. So it's 155.29 degrees. Now the question is this too big? Added to B, are we still below 180? All right, so here's B, right? So yeah, 20 plus 155 is 175, right? So this is what tells us that there's two triangles. So since A plus, B, not A. Since B plus C1 is less than 180, and B plus C2 is also less than 180, degrees, right? Of course. Then we have two triangles. Does that make sense? Like how you determine? That's going to be I think this is the hardest type of question in 9.2. The rest are pretty chill, I think.
So does the A angle just fill in the gap to 180 on both triangles?
Yeah, exactly. So just the A will be determined by these two C's.
Okay.
So let's go ahead and do that, right? So the first C1 we said was 24.71 degrees. C2 was 155.29 degrees. So 180 minus both of these and both of these would give us two different A's, right? So what is A1?
$135.29.
Yeah, 135.29. Thank you. And A2 is going to be what?
.71.
Yeah, it's small, right? But it's still a triangle. Okay. So we're almost done. Do you guys have any questions so far as to what we just did?
You said that you weren't gonna give us like the second A2s and stuff, right? That you just wrote that up. But how did you know B2 was 20 and the small
Oh,
one was
right.
9?
So this was given to us, right? B equal to 20 and little b equal to 9 and C is equal to 11. So these right here are the ones that are given in the question.
Mhm.
So since it's fixed, then there will not be another one. They won't
Okay.
change
Okay, gotcha.
because I already know what B is.
Two triangles, then we can use the same stuff.
Mm-hmm.
Okay,
Because like if you were solving for B, then you'd have two different B's as solutions like we did here with the C's. But since I already have the B, you wouldn't be doing this.
okay, I got you. Thank you.
And Jack, for A1 equals 135.29, you said we're doing 180 minus the 24.71?
Yeah, so when you have two angles, you just take those two angles away from 180 and the leftover will be the last angle.
Well, I'm getting something different. Am I doing something wrong?
You said
I'm getting 155.29.
So you could put 180 minus 20 and minus
Oh,
24,
180 minus 20.
and then minus 24.71. That should give you the A that was missing earlier. And then do it again.
Okay, I got it.
You got it?
I was missing that 20. Okay.
Okay. Alrighty. So now all we got to do is find little A1 and little A2, and we're done. Okay, so I'm going to use the exact angles and sides to help me find these A's here. Right, so it's going to be the exact same formula. So I'm just going to show you real quick. It's going to be A over sine A equal to B over sine B, which is equal to, so solve for A and we'll get A equal to B sine A over sine B. There we go. So all we have to change is the A. That will give us two different A's. So A1 would equal to 9 times sine of 135.29 over sine B, which is 20, sine 20. Try to get it a little higher there. Okay. So, and then for A2, it'll be the same thing. You just, down, my pen died. A2 will simply be the same deal, but you're going to change this A in here, right? To be 9 sine of 4.71 over sine 20. Does that make sense? Why I did that? Right, because we're using this formula, right? Little a is equal to this, so you're gonna A1 is going to be determined by capital A1. A2 will be determined by capital A2. That's what we did. Everything else would be the same because I'm using the B's. And any questions on this?
No.
Okay.
So I was just wondering the reasoning behind A equals B sine A over sine B. Like, how did we get that?
Oh, sure. Yeah. I skipped an algebra step here. So what you have to do is multiply both sides by sine A. That will cancel this sine A, which will then put it on top, right? Do you see? You multiply sine A on top here and on top there. That gets you to here.
Okay. Yeah.
You want me to write it out or do you see?
No, I see it now.
Okay. Okay. Yeah. Just let me know. It's not a big deal.
So for A1, I got 18.51.
Let's see. 18. Yeah, that's right. 18.51.
And A2, 2.16.
2.16. Yeah, that's good. So we found the two triangles and we're done. I hate when there's two triangles because it's more work, but it happens. The one with least work is when there is no triangles. You just need to be able to spot it. Okay. That's pretty much it for, let's see, 9.2. So 9.2, just remember you'll be using law of sines, and you always check if there's a second triangle. And if there is, well, you got to go through this process. While you're solving for an angle, if you get an error, then there's no triangle. But make sure that you set everything up correctly before you make the assumption. Okay. Alrighty, let's go ahead and start 9.3, I suppose. First, let me check the syllabus. So 9.3 is the law of cosines. So in this section, you should not run into two triangles. That only shows up if in scenario case 1 and case 2. So this is 9.3, law of cosines. So this is great when you have nothing but sides and no angles. Or if you have two sides with no corresponding opposite side. This is when you have to do law of cosines. So here's the theorem and formulas. So number 1. Okay. Double check these. Yeah, it's fine. little c is equal to the square root of a squared plus b squared minus 2ab cosine capital C. And by the way, for these formulas, just imagine some triangle like this, right? A, B, well, actually, I put C on the top, right, originally. It doesn't matter, but I'm trying to stay consistent. You guys remember the original formula?
Mm, No, never.
Let me check then.
From 9.1?
Yeah, 9-1. and-
Yeah, because I think that confused me a little bit, but yes, I think you put the C on the top.
Okay, yeah, it doesn't matter where it goes. I'm trying to stick this to the same thing we did in the notes. The only thing that needs to be specific is these letters have to be the same. So A, capital A is opposite to little a. Capital B is opposite to little b. As long as you set it up that way, then it doesn't matter. Okay. All right, so formula 2. The equation for little b is equal to a squared plus hold on a second. That looks like a typo. Doesn't seem right. Let me look at the book. One moment. I don't want to give you a fake formula because that would be mean. That would be pretty mean. Let's see here. So little b, yeah, I thought so. This should be a squared plus c squared. I had an error in one of my old notes. 2ac cosine b. All right. Little a is equal to the square root of b squared plus c squared minus 2bc cosine a. So I'm trying to make these formulas easier for you. So the reason I was double checking is because I made these from the ones in the book. So if you take a step further, it'll be really easy. So now if they ask for A, B, or C, then all you gotta do is plug stuff in. You don't have to do anything extra because I already saw for them. Okay, same thing. And this is the same for, of course, this wasn't much work, but these next ones are a little bit more work. So I hope you appreciate it. So here's capital A equal to cosine inverse of all right, let me double check everything because these need to be perfect. Bottom part will be 2bc. Top part will be yeah, b squared plus c squared minus a squared. So if you use this one without doing any work, you'll get the angle A automatically. This will save you some formula stuff. The book has a different setup, so it's if you use there, it'll be different, but it'll require you to do more work. You'll have to do this yourself. If you use mine, you don't have to. Capital B is equal to cosine inverse of 2ac on the bottom. On the top, we should have a squared plus c squared minus b squared. Capital C will equal to cosine inverse of, let's see, 2ab. On the bottom, top will be a squared plus b squared minus c squared. Okay. Okay. All right, let's start the examples. This is all we will need. Example 1. Okay, so the homework will start out with just saying, solve this triangle. And they give you a picture. So here is my attempt to draw that picture.
Oh, it's kind of groovy.
Here's B, and again, they change the placement of these angles, so whatever. 106 degrees, 4 and 2. So notice how these angles, notice how this angle does not have an opposite side, right? And the missing angles do have opposite sides, but the angles are not given. So this tells us that you have to do law of cosine, because you cannot do law of sine without an opposite side. Okay? No choice.
So law of cosine needs to have an opposite side.
Law of sine does.
Law of sine needs to have a opposite.
Yeah, the given angle needs to have a opposite side. One moment. Okay, so let's go ahead and find the missing side. We could do that because we have these sides and an angle, so we should be good. So little c is equal to a squared plus b squared minus 2ab cosine c. Now I have all those things, right? I'm gonna write them out over here. I have a, that is kind of helps to write it all down. B is 4, c is missing, angle is missing, angle is missing. This angle is right here. Okay, so plug it all in and we'll have one of the sides. All right, so that'll be 2 squared plus 4 squared minus 2 times 2 times cosine of 106. So what is that going to be? Let's plug it in our machine. So square root of 4 plus 16 minus 4 times cosine of 106. Did you guys get 4.5?
I have a quick question.
What's up?
So on the equation, it says 2AB. So I thought you would do the 2 times the 2 for the A and then the 2 times the 4 too.
Yeah, that should be a 4, right? Yeah, I see what you're saying. Thank you.
It's a 2 and a 4, right? 2 times 2 times 4, or no?
No, just yes, that's why I got confused. Okay, thank you. No, I forgot there's a built-in 2 in there. It's 2 times 2 times 4. The 2, 2, 4 cosine of 106. Okay. So that would be what? 16, right? Cosine. Okay, I got 4.94.
Me too.
So that is my little c here, 4.94. Okay. So now I got all three sides, which is required to find the angles, right? Using the law of cosines. So I'm gonna find angle B now that I have these. So B is equal to cosine inverse of 2 squared plus 4 squared minus c squared. Where is it? Yeah, 4.94.
Well, for B, wouldn't it be 2 squared plus 4 squared minus 4, or 2 squared?
Yes, yes. Sorry, guys, I'm getting really hungry right now.
Since we rounded for C on that, is it okay just to use the rounded?
Yeah, that'd be fine.
I didn't, but if we round for the C, are you okay to use the rounded for this?
They should
part of
tell
it?
you like how to round, like how many during the process and how many at the end.
Okay.
Okay, so this will be 2 times 2 times 4.94. Okay. Any questions on where this is coming from? These numbers. Okay. All right, so what did you guys get for B?
105.98. Is that correct?
105.98. I think so. Let me check.
No, I did it wrong. I didn't follow your numbers up here. I switched it up.
Yeah, yeah, I think you're right. Let me do it too. I didn't do it this time. So 4 plus 4.94 minus 16 over 4 times 4.94. I got
Got a negative 74.837. I don't know if that's right.
should be positive.
Hmm.
Capital B. You did cosine inverse, right?
Oh, no, I didn't use cosine inverse. Nope. I forgot that one.
Have 51.118, so 51.12.
Yeah, that sounds right. 51.12
So,
sounds good. So now what is A? So subtract from 180, right? Did I do that right? You guys get 22.88 for A?
Yeah.
Okay. So we don't have to use the formula again because we already had 2 angles, which means we can find the missing angle with the 180 idea. Okay. Any other questions on this? Because we found all the sides and all the angles. Okay. Yeah. Oh, sorry. Was there a question? There's no rush here. Plenty of time. Okay. So let's do this next one. The next question, they're only going to give us 3 sides, no angles. Solve the triangle this time just to make it simple. I'm going to just give you the sides here. I don't have the angles. We don't know what they are. A is 3. B is 5. C is 7. Okay. So the formula for A is going to be cosine inverse of B squared plus C squared minus A squared over 2BC. So that would be cosine inverse of 25 plus 49 minus 9. And then the bottom will have 2 times B times C. Okay. What do you guys get for capital A?
Are we supposed to plug that whole thing in the calculator?
Yeah, you'd plug it in just like this. Can you see?
21.79.
Yeah. So cosine inverse, and then you plug in all the numbers. If you don't have the fancy fraction thing, you just put parentheses on the top, divide parentheses.
Okay, so you have to put the parentheses on the bottom when you
Yeah.
divide it.
Yeah, if we, let's
That's
pretend
why
you
I'm
don't.
like, yeah, okay. I
let's do it
couldn't
the other
figure out
way.
why I wasn't getting it.
Okay, cosine inverse. So the way you would do it, you'd be 20 parentheses first. So 25 plus 49 minus 9 parentheses divided by parentheses 2 times 5 times 7. Close the bottom parentheses. Oops. Close the cosine parentheses. And that will give it to you. So you put the numerator in parentheses, the denominator in parentheses, and then your cosine has its own set of parentheses. Then it should work. The fraction button just makes it a little easier, but it's not necessary. It's just pretty.
$21.79.
Okay. So you got 21.79. So that means that we need one more angle, and we can find the last one with the 180 idea. So capital B. Let's use this formula. That'll be cosine inverse of 2ac a squared plus c squared minus b squared. There you go. So be cosine inverse of. Sorry about that, guys. Hold on. Give me one moment. All right, guys. So plug in all the numbers and we'll be pretty much done. Let's see. This will be 9 plus 49 minus 25 over 2 times 3 times 7. So what did you guys get for big B?
38.21,
Cool. Thank you.
right?
Yeah, that's right. All right, so now that we have B, we can find C with the 180 idea. So what is C? Right, 21. Minus
20 even.
120?
Yeah.
Nice. Okay. So we have all our angles and we're given all 3 sides. Any questions on any of the steps?
One more time, how did you get C?
Like this. So you take 180 and you subtract all the other angles. So you subtract A and B from it, which would be 180 minus 21.79 minus 38.28 degrees. So that gives us 120. Okay. No other questions on this example 2? Okay. Example 3, you can use whatever you like, law of cosine or law of sine, it's up to you. We'll just tell you solve the following triangle. Okay, so they're going to give you the A, 46, capital B, which is 37, C is 97. Don't have little a, I have B equal to 20, and little c is something. I don't know what that is either. So notice how we have an angle with its opposite side. So you could use law of sines if you wanted to. And since we have ABC already, then that tells us it is a triangle, right? It's one triangle, obviously. There's no way a second could appear. So you can use law of sines, you can use law of cosines, it doesn't matter. So I'm just going to use law of sines just because. So A over sine A is equal to B over sine B. Solve for A. That would give us this formula right here. B sine A over sine B, which would be 20 sine 46 over sine 37. So that would be approximately what?
I got 23.9.
Yeah, that's right. 23.91, I guess. So now do the same thing for little c. C over sine c is equal to, I'm going to use middle one again just because they were given. Oops. B.
Yeah,
Oh, yeah. Sorry. B over sine B. Solve for C, doing your algebra. That would give us C equal to B sine C over sine B, which is 20 sine 97 over sine 37. Yeah. So what is that? Actually, that's not an angle.
Is it 32.99?
Yeah, 32.99. 32.9. So you see how you could use law of sines or law of cosines. It's up to you. Doesn't really matter. I guess we'll stop here with 9.3. I'll save 9.4 for next time. You guys have any questions on chapter 9 stuff at all? Like from 9.1, 9.2, or 9.3?
So it's just that sometimes, you know, we do this stuff with you
Mhm.
and it makes sense, right? It's like, okay, cool, we got it. And then when we do homework, there's fractions, like there's stuff that you don't even go over in the homework. Would anything like that pop up on here, like weird fractions?
I mean, fractions are always fair game. I could have a side that's 7.2. I could have a 5 halves. Sure. Yes.
Could we do an example with a fraction or a decimal? I mean, well, not a decimal, mostly like a fraction. Like,
I mean, it'll be exactly the same. You just need to plug them in with your extra parentheses. So instead of having like a 25, right, you'd have to put an extra set in your calculator. So like, let's say, let's just pretend, right? Let's say that this was, well, I don't want to mark this one up yet.
if you just want to show us in your calculator, I could just come back to the recording.
Oh yeah, okay. So let's pretend that the numbers we're plugging in are ugly, right? That's what you're talking about. So let's say our b squared would be 5 halves squared. So you would have to, assuming you don't have the fraction button, right, for this part, or no?
I do.
You do? Okay. So if you do, it'll be a little bit prettier, but it'll still be annoying. You'll have to put parentheses for each fraction. You'll have to put 5 halves and square it. And then you have to put plus, let's say the other one is another fraction. You'd have to put it in parentheses to be safe. So like 4.2 squared minus whatever the other number would be. Let's say it's, I don't know, 1/2, right? So you could do it this way, or you could use the division symbol for each one, or the fraction. You can change these into fractions, but you just have to make sure when you square it, you put parentheses. That way it won't mess up. Okay, so even if it's pretty numbers or not, put them in parentheses. That way you won't make a mistake. If you get in a habit of just always putting the parentheses on powers, I think that might save you some of the headaches. But if you don't have that, you would have to do it like this, which should be, it's not going to be pretty, but you have parentheses at the top. So you'd have like 5 halves in parentheses minus, let's say it's 2.7 or something. That would need to be in parentheses 2. And then say minus, we had 1/2 earlier, so we'd have to put that as 1 divided by 2 squared. So then you would close that off and then divide again, create a new set of parentheses. So you see how you have to put it on every single fraction or value. That way you won't make a mistake. So the numerator has a set, each term has a set. That way nothing can go wrong. But it starts to get really messy. So you be very careful. So the parentheses for the bottom, if you have fractions on the bottom, you have to do the same deal. You'd have to put parentheses for the bottom part and then a set for each fraction. So like 3 halves squared. Oops. Just to be safe. You see what I mean? So once you have all those, you close it, So this set of parentheses here and there corresponds to everything in the denominator. Okay, so be very careful. So this entire chapter is going to be calculator heavy. So make sure you use your parentheses accordingly. Okay. And I need you to get more comfortable with fractions when, I mean, it won't be a big issue in this chapter, but I don't want you to avoid them.
Copy that.
Because see, they're going to keep coming up and they're going to keep bothering you. Okay, you guys have any other concerns or questions?